Core data. Core data is a framework that lets you express what your model objects are and how they are related to one another. This chapter will give you an understanding of core data as you add persistence to the Photorama application. Core data versus circle. Often you will have your core data save your object graph to a circle-like database. Unlike an ORM, core data takes complete control of the storage. You do not have to describe things like the database scheme and foreign keys. Core data does that. Core data uses different terminology to describe these ideas. A table type is called an entity, and the column's properties are called attributes. A core data model file is a description of every entity along with its attributes in your application. Entities. Open Photorama project. Create a new file. Select iOS at the top and scroll down to the Core Data section. Create a new data model. Name it Photorama. Add an entity named Photo. Now your photo entity needs attributes. Remember that these will be the properties of the photo class. For each attribute, click the Add button in the Attributes section and edit the attribute and type values. The photo ID and title are string type, and date taken is a date. The remote URL is a transformable. It is a URL, but that is not one of the possibilities. With a transformable attribute, core data will convert the object into a type that it can store when saving, and then convert it back to the original object when loading from the file system. With the Photorama data model still open, select the remote URL attribute and open its data model inspector on the right-hand side. Under the Attribute section, enter NSURL as a custom class. This will allow core data to do the transformation for you. In the project navigator, select the photo.swift file and move it to the trash. Open Photorama data model. Select the photo entity and open the data model inspector. Locate the CodeGen option and select Menu None. With the photo entity still selected, open the Editor menu and select Create NS Managed Object subclass. On the next screen, check the box for Photorama and click Next. Check the box for the photo entity and click Next again. Xcode can generate NS Managed Object subclasses for you based on what you have defined in your core data model file. The template will create two files for you, photo plus CodeData class.swift and photo plus CodeData properties.swift. The template places all of the attributes that you defined in the model file into photo plus CodeData properties.swift. If you ever change your entity in the model file, you can simply delete photo plus core data properties.swift and regenerate the NS Managed Object subclass. Xcode will recognize that you already have photo plus core data class.swift and will only recreate photo plus core data properties.swift. Core data stack. Core data is represented by a collection of classes often referred to as the core data stack. This collection of classes is abstracted away from you via the NS Persistent Container class. NS Persistent Container will manage the interactions between the application and core data. Open photo plus core data properties.swift and take a look at what the template created for you. All of the properties are marked with the @NSManaged keyword. This keyword, which is specific core data, lets the compiler know that the storage and the implementation of these properties will be provided at runtime. Because core data will create the NSManaged object instances, you can no longer use a custom initializer, so the properties are declared as variables instead of constants. Any custom properties or code that you want to add should be added to photo plus core data class.swift. Let's fix some of the errors that are in the project. Open photostore.swift and find fetchImage for completion method. Update the method to address these issues. To address the first issue, you are using a guard statement to unwrap the optional NSURL. To address the second issue, you bridge the NSURL instance to a URL instance using an ascast. The compiler knows that NSURL and URL are related, so it handles the bridging conversion. You have created your model graph and defined your photo entity. The next step is to set up the persistent container. There are still some errors in the project. You will fix them after you have added a core data persistent container instance. In photostore.swift, add the persistent container property. To use core data, you will need to import the core data framework in the files that need it. You instantiate an NS persistent container with a name. This name must match the name of the data model file that describes your entities. After creating the container, it needs to load its persistent stores. The store is where the data is actually stored on disk. By default, this is going to be a SQLite database. The model file is an instance of NSManaged object model, where you define the entities for your application along with their properties. Core data can persist data in several formats. SQLite. Data is saved to disk using a SQLite database. This is the most commonly used store type. Atomic. Data is saved to disk using a binary format. XML. Data is saved to disk using an XML format. This store type is not available on iOS. In memory, data is not saved to disk, but instead is stored in memory. The mapping between an object graph and the persistent store is accomplished using an instance of NS persistent store coordinator. The portal through which you interact with your entities is the NS-managed object context. When you ask the context to fetch some entities, the context will work with its persistent store coordinator to bring temporary copies of the entities and object graph into memory. Unless you ask the context to save its changes, the persisted data remains the same. Updating items. With the persistent container setup, you can now interact with core data. The view context is an instance of NS-managed object context. Inserting into the context. When an entity is created, it should be inserted into a managed object context. Open Flickr API.swift and import core data. Next, update the photo from JSON method to take in an additional argument of type NS-managed object context, and use this context to insert new photo instances. Because you are returning the result of the insert operation from the photo from JSON into method, you use the synchronous method perform and wait. The photo from JSON into method is called from the method photos from JSON. Update this method to take in a context and pass it to the photo from JSON into method. Finally, You need to pass the view context to the Flickr API struct once the web service request successfully completes. In PhotoStore.Swift, update process photos request method. Build and run the application now that all errors have been addressed. Although the behavior remains unchanged, the application is now backed by core data. In next section, you will implement saving for both the photos and their associated image data. Saving changes. Recall that NS managed object changes do not persist until you tell the context to save these changes. Open PhotoStore.Swift. Update fetch interesting photos method to save the changes to the context after photo entities have been inserted into the context. Updating the data source. One problem with the app at the moment is that fetch interesting photos method only returns the newly inserted photos. Now that the application supports saving, it should return all of the photos, the previously saved photos as well as the newly inserted ones. You need to ask core data for all of the photo entities, and you will accomplish this using a fetch request. Fetch requests and predicates. To get objects back from the NS managed object context, you must prepare and execute an NS fetch request. After a fetch request is executed, you will get an array of all the objects that match the parameters of that request. In PhotoStore.Swift, implement a method that will fetch the photo instances from the view context. Next, open PhotosViewController.Swift and add a new method that will update the data source with all of the photos. Now update view.Load to call this method to fetch and display all of the photos saved to core data. Build and run the application. If the application runs multi-times, and the same photo is returned from the web service request, it will be inserted into the context multi-times. This is not good. You do not want duplicate photos. Likely there is a unique identifier for each photo. In Flickr API.Swift, update photo from JSON-in2 method to check whether there is an existing photo with a given ID before inserting a new one. Delete the old application. Build and run the application again. The photos will appear just as they did before introducing cool data. Duplicate photos will no longer be inserted into the core data. Challenge: Photo view count. Add an attribute to the photo entity that tracks how many times a photo is viewed. Display this number somewhere on the Photo Info View Controller interface. See you next time.